Good morning, everyone. My name is Stefan. I will talk today about technical data. Sounds like a boring topic. Before I start, I would also like to ask one question. Who is working for a company that is manufacturing physical things, not software? Okay, this is not the majority. So I'm working for such a company. We also develop software, but it's not the core. And the goal of this short presentation is to talk about a plugin which is processing technical data. Unfortunately, this plugin is closed source, so by contract, everything that I code is owned by the company I work for. But I could ask to release the code, but to ask, I would need to see some interest in the code. Otherwise, it does not make sense for me to ask. So if you are interested in what I'm talking about, talk to me after the presentation, send me an email and so forth, and then we can try to find a solution which does not violate my contract. I'm working for Dometic. Very short introduction to give you a rough understanding of the company. Dometic is a Swedish company. We are stock listed. We have 9,000 employees and sell products to more than 100 countries. If you are dealing with compliance, this raises a lot of complexity. So most of the sales is done in the Americas, but EMEA is also the strong market for us. We have a very broad product portfolio. We are active in many different markets, mostly in the RV market, but also for passenger cars and leisure marine. We have quite a few solutions. We are quite big in residential, but also in CPVs, professional marine and hospitality. We have many different products, thousands of products, and this really raises a lot of complexity for us. A few words about myself. My name is Stefan Jung. I got married a few weeks ago, so my former name was Stefan Eike. I'm the global head of technical documentation. I'm leading a team of 2 internal people and 20 external people. So the translators are not included in the numbers. I'm living in Greven in North Rhine-Westphalia in Germany. I'm married and have 2 kids. I'm a technical writer and also a media computer scientist. And I wrote some of the DocTales open source DITA plugins a few years ago. And this is me. So the challenge that we have in the company is to deal with technical data in manuals. As you know, you are all familiar with DITA. DITA has a few hundred elements, but not much elements about machines and physical things. A lot of these elements are used for virtual things, for software and buttons and variables and stuff like this. So there is not an element for technical data. Technical data is for us in a manual very important. And as I explained at the very beginning, we are selling products to different countries. And here we have also different requirements, what technical data have to be named in a manual and how the technical data is written. We have thousands of technical standards on this planet, but still we have a lot of variety when it comes to technical data, how it is represented and so forth. So how does it work today or before we started to move to DITA? In a FrameMaker environment, we had tables like this. Here you can see we have conditions on table rows and table cells. This is quite a common example. Here you also can see we have temperatures in Celsius and Fahrenheit. Sometimes we have ranges this adds a lot of complexity. In a manual for the EMEA region, you maybe do not want the Fahrenheit values, only the Celsius values, or you want the metrical values, not the imperial values, and so forth. So it's a very boring problem. And how you can solve the problem is that you add a lot of conditions on all these things in FrameMaker. You can do the same in DITA, but it's very time consuming and it's very error prone and it's expensive at the end of the day. Also, when you do translations, you pay a translator to replace a decimal point with a decimal comma or the other way around. This is human work. This is very expensive, and it does not really make sense to let a human do this. So sometimes the technical writers even have to calculate between SI and imperial units. So this is really not state of the art, but with pure DITA, this is what we have to do. So let's try to automate this. How can we do this? Of course, we need some semantics to represent technical values. And I've created 2 new elements. The first element is called TV for technical value, and the second one is called TV range for technical value ranges. Not sure if the names are great and easy to understand, but I didn't have a better idea. So the challenge is, what do we want to do? We want to do automatical conversion of technical values between SI and imperial units. We also want technical unit-based handling of decimal places. So sometimes you want 3 decimal places and sometimes you want 1. It depends on the technical unit, on the use case. So it's also a challenge. Sometimes you want the SI and the imperial unit to be shown in this order or the other way around, or only one of them. Everything can happen. And this is also something which is driving me crazy, that technical units, even if they are standardized, they are localized. So if you write 10 millimeters in a European manual, you would write it like this. And the Russians, they translate the letters to Cyrillic letters. So this is also something that you have to automate. And yeah, decimal separators. Half of the word is using the comma, the other half is using the point. And as a technical writer, you also want what you see is what you get support. So you want to see what you have modeled in the XML code, also in the Oxygen author mode. So it's not UCOM. UCOM is a unified code for units of measure. It's an organization. This has pointed out to me by Jan Grad. Thanks a lot. I was not aware of this organization, to be honest. So this organization is providing some XML grammars and also some codes to do something similar, but it's not really compatible with DITA. It's a good information resource, but we cannot integrate it as it is. At least I was not able to do it. Some examples. So this is quite easy to understand. The first example is the most simplest example. You have the TV element with the value 1, and you set the unit attribute. This is mandatory to centimeters, and then you will get usually an output of 1 centimeter. You can also set the system attribute to SI, then the result is the same. In the third example, I've set the system attribute to imperial, and then we get a return value of 0.39 inches. So the value itself is still in centimeters, but it's automatically converted to the imperial counterpart. You can also set systems to SE plus imperial, and then you get 1 centimeter and in brackets 0.39 inches. You can also hide the unit when you set the show unit attribute to no. And you can also prefix a custom technical sign by setting the sign attribute. This is the last example. So this is basically what it does. And then we have the TV range attribute. If you want to represent ranges, it's basically a convenience attribute to set a character between the technical values. So this can be done here by setting the separator attribute. So as I said, the decimal separator is a problem. How does this work technically? We are looking at the closest XML lang attribute, and by validating the value of the attribute, we determine the decimal separator. The decimal places can be defined in format number patterns. We use the variable mechanism of the DITA-OT toolkit to store these patterns. So we can, as I said at the very beginning, use different patterns per technical unit, which is quite flexible. It's quite similar with the localization of the technical units. We have also the variables functionality, and here we have a file called mal.xml. Here we represent the default representation of technical units. So here we have WETs. This is used in all the Western languages. And we have another file called AR.xml, where we have the Arabic value, and another one for the Russians. The Thais also use a different representation of the technical units, so it's a lot of complexity. Yeah, and we are coming to the end of the presentation. What you see is what you get in Oxygen Author View. We also have integrated the same functionality in a convenient way using the oxy-xparse function. It's a custom Oxygen extension to CSS, and here you can use xparse expressions in CSS directly, so that the conversion is done in the Oxygen author mode on the fly. And we also have a PIM system. This is also a very important aspect for us. We have in this PIM system, we store technical values for all the products, technical data, and so forth. And this technical data is used on e-shops, websites, or dealers. And this is also a very interesting technical data for us. In the past, this was more or less copy and pasted. This was the common approach. It was a valid information resource, and the technical writer copy and pasted these values to FrameMaker. And this has been automated. It was very convenient to do this with Oxygen as well. We used a few ARN scripts to do this. So we got the technical data from the REST API with some curl statements, converted them to DITA automatically, and then we store some what we call warehouse topics with technical data automatically in the Git repository. And here we also automatically create these technical value elements. So we have closed the circle, integrated our product information management system, and can then dynamically decide when we publish the output how technical values should be represented. So thanks for listening. I'm out of time now. I don't have time for question and answers. So if you would like to talk about this plugin and what we did, please simply talk to me in the coffee break. And also from my side. Thanks a lot for your attention, and also to Synchrosoft for organizing this event. Thank you.
Thank you.